Okay, now I'm ready. Hello, everyone. Do you hear me? I believe you can hear me clearly. This is Henry Kim, as Dr. John introduced me. It's very simple introduction. It's good for us. Good evening here in Korea, the Korean colleagues, and good afternoon somewhere in other country. Oh, Dr. Tahun, I can see you. Thank you for participating this time. Thank you again for all the participants today. It's good to have a chance to talk with you, talk about the topic irrigation and obturation in the minimally invasive endodontics. So thanks to ATIS again for inviting me today. I believe most of you had vaccinated struggling with the COVID-19, so it's not easy to travel like before the COVID outbreak. For me, actually, this year, 2021, I had never been outside overseas country. Actually, I have never take flight even one time. So I miss it. So today I show you some photo of my city, Busan. Busan is the second largest city in Korea. This is small part of my city, Busan, actually around my residential area. This is the night view. You can see the big bridge. The name is Gwangan Big Bridge. It's actually around 6 kilometer length, quite a long bridge. Nighttime view, and sometimes sea cloud makes a fantastic view. Maybe some of you may feel scary, maybe. Anyway, I like this mood. If you come to Busan after the COVID has gone, you can enjoy the boat cruise and you can see the scenery of this downtown and the mountain together. And you can enjoy the famous food of raw fish. This is the most popular one here in Busan. So sometimes the fish body comes together and here you can see the fins are still moving. So maybe someone may feel scary, but no worry, it's not alive at all. But somebody enjoy this moving meat, fish meat. Let me start today's topic. We are quite familiar with the minimal invasive dentistry, but you can see the small letters. Drill free, no, we have to use the drill. Needle free, no, we have to use the needle too. Fear free, oh, I don't know. I sometimes lay myself on the dental unit chair once a year. I fear fear. I think the minimal invasive dentistry is, in another word, conservative dentistry. That is my major in Korea. It aims to keep our natural tooth as long as possible by keeping the tooth material as much as possible. That is the concept. The enameloplasty, they are examples. When we found initial caries on pit and fissure caries, we may try to remove just that pit and fissure and reshape the pit and fissure without any actual cavity or actual fillings. It's a kind of preventive procedure. And this is laser surgery figures or gingivectomy without using blade. It may bring a small wound and may bring better healing in a short time. This is Maryland Bridge, we call it. It's also kind of minimally invasive prosthetic treatment with minimal preparation on the abutment. But actually, when we compare with the implant, Maryland Bridge itself is kind of more invasive one. Implant itself is a kind of minimal invasive because we can preserve without preparation of the abutment tooth. And for implant surgery, the socket elevation technique instead of sinus window opening is also a minimal invasive treatment in terms of not to make a big bony window, right? So these are all the examples for the minimal invasive dentistry. Then how about in endodontic procedure? The first coming idea is minimal invasive access cavity. For some clinicians and for some researchers, we call it conservative access or ultra conservative access. Sometimes we call it ninja cavity. I don't know why they call it as ninja cavity, but it is extremely small and somewhat different from our conventional, not somewhat, very different from our conventional idea that we learned at school. So the access cavity should give straight line access, but actually in this case, you can see the upper part to get the straight line access. It's too small. Let's think about the basic principle of endodontics. I like this figure. It tells all about the endodontics. You can see here the irregular canal spaces and apical lesion at the third tooth. Of course, it is impacted one. And then next, after root canal shaping, it means after removal of impacted pulp tissue and microorganism, the apical lesion will begin to decrease, as you see in the figure. This is the healing procedure. Even in case we have normal and we cannot make a perfect clean by using any good file systems or any expensive file systems. We know that. This is the limitation of mechanical shaping. Of course, it's good to aim a minimal invasiveness for tooth material preservation, but we have to think whether we can remove microorganisms as much as possible through the conservative or very small access cavity, ultra conservative access. Actually, I don't like this concept. As the main purpose of root canal treatment is removing microorganisms, all we agree that. The most common endodontic failure is coming from microbial factors. As you see here, whether it is inside of the root canal or outside of the root canals, or related with the microorganisms. Of course, we have to take care about the mechanical failure, of course. I will tell you those again later. This is a general procedure of root canal treatment from access opening to the end, the post-endodontic restoration. We all very well known about this. Among them, we can consider the minimal invasiveness for these colored steps, the access preparation, canal shaping, and filling. Let's have a look at these access cavities. There's many kinds. Here in the left end, you can see the traditional access cavity, and the second is conservative access, and in the center, you can see ultra conservative access cavity. The next one is truss access. We call it as truss. And the last two in the right side, I don't want to even announce these two methods. They are not good trial. Anyway, how can we shape, irrigate, and obturate the canals with these small access cavities? Without microscope, without ultrasonic tape, it's almost impossible. So I would say this minimal invasive trial is only for the specialist who use the microscope and ultrasonic instrument. Here I have one study about the access cavity design and the lifespan of the tooth from the different access cavity design. We compared the traditional access cavity, conservative access, and truss access by using final element analysis. You can see the simple result in the table. The larger access cavity showed the bigger stress generation. And according to the stress increase, the lifespan of the tooth is going to decrease. Of course, this is good point from the minimal invasive access opening. This is good point. But the dental microscope should be with us. Without this, it's almost impossible. Only microscope can give us illumination and magnification of the purple floor. If we select the conservative or trust access, it should be mandatory device and we have to use this expensive microscope. By the way, how often do you think we can make this ultra conservative access? We always have some reason to do the root canal treatment. And the reason is usually we have caries dentin, caries cavity, and previous restoration. Usually they are quite big. Then we have to remove all of them, right? So the cases root canal required, they already have some cavity destruction. So it's quite difficult to get the chance to make the ultra conservative cavities. So this is the clinical practice. Actually, the researchers trying to do some effect from the ultra conservative access and trust access, something like that. But in the clinic, in our practice, it's quite difficult to see the real cases of that small access cavity design. Let's think about the radicular access cavity, to finding out the canal orifices. It means that the orifice spreading as well. We know that the straight line access is very important. So we are saying access is key to success. To make successful radical access, we always need to remove the dentin shelf at the purple floor level. We know that as the right side figure. It is kind of mandatory step to make straight line access to the mid-root canal spaces. The dentin shelf increase the file bending and finally it may increase the risk of fracture at this level. So the files used for this cervical area, it's better to have higher fatigue resistance because we may use brushing motion with some pressure to change the file direction to remove the cervical dentin shelf. So it's better to use heat-treated instrument because the heat-treated instrument, they usually have higher fatigue resistance. Here, I show you some file system from the inviting company 80s. I have to announce some material from the 80s. Am I right? So here is two file systems, eFlex Gold, eFlex Blue. These two file systems have orifice opening instrument with the size of 17, 8% taper. Because they were heat treated instrument, they are quite flexible. As you can see the drawing, they have very good curvatures of the file itself. You can use it in a curved condition to make a straight line access and with minimal risk of fractures. I once studied with Dr. Pedrola from Italy. We compared the file's fatigue resistance under the condition of different file insertion angles. If we have a small access cavity or big dentin shelf area, the file will have higher stresses and higher risk of fatigue fractures. This study was conducted with Rashbrook Blue. Although this is the file Rashbrook Blue is heat-treated instrument, and also reciprocating file, we found that the excessive insertion angle significantly reduce the fracture resistance. So we can say we have to think again the stress generation under the minimal invasive access cavity. That's why I don't like the minimal invasive access cavity. It's good to have the traditional conventional access cavity, I think, in my practice. We have lots of nitride rotary file systems. I think you may have two or more brands in your clinic. Maybe some of you, one of you at least, may have files in your pocket right now. So we can classify all of these instruments as four groups. Whatever groups they are, all file systems, nickel titanium file systems are good enough and they are much better than stainless steel instrument. But when we select the instrument, I think we have to consider the root dentin integrity because some file system is quite a hazard for their integrity and the future progress of the root canal treated tools. I'm going to talk about the file's properties in terms of root dentin preservation, and minimal invasiveness. The root dentin integrity, it is directly related with the endodontic prognosis. So we did the final element analysis study. This is the root of final element. And inside of this model, we have rotated the final element file models. You can see the simulation motion. The file rotated inside of root canals. We could calculate the stress generation and we could calculate the stress value, not only for the nickel titanium instrument, but also for the root dentin near the apical foramen. You can see the color change. Red color means very high stress generations. In this study, we compared the pro-taper profile and light speed. As you guessed, the steeper pro-taper shows a higher stress on the apical root dentin. Under the condition of this study, the apical stress by pro-taper and also profile were almost similar with the dentin's tensile strength. It means that you can see the number values, 100 something, and the dentin's tensile strength is 106. So we would say that some file systems or a certain size of file may threaten the root dentin integrity and may produce an apical micro cracks. So we have to care when we select the instrument, proper instrument. My major research scope is the geometry optimization of the nickel titanium instrument and comparison of their fracture resistance. Some other researchers reported that the center core area, you can see the round one in the cross section. The center core area is the kind of main factor to decide the torsional fracture resistance. But we are not sure about it, so we made four standard models with same cross-sectional area or same center core area. From the left side, oh, sorry, coming back again. From the left side, triangle, slender rectangle. The third one is rectangle with a big center core area, and the last one is square. Triangle and slender rectangle, those two have same cross-sectional area, and the third one has the same center core area with the first one. Let's see the simple result. Although the second slender rectangle has this smaller center core area, you can see the small round one, but it has a higher torsional stiffness and strength than the first triangle one. So we can conclude, the center core area is not the main factor, but the shape or total area of cross-sectional area, total cross-sectional area is the main factor to decide the torsional resistance. The pacifier, you are familiar with this. You may know this, right? So the pacifier has square cross-section. the square has the highest torsional strength from this study. As you know, the taper of PASPAR is just 2%. It is very thin and tiny file. When we use this in a very calcified small canal, it can endure without any fracture. It's not so easily broken. The reason why this thin and tiny file with minimal fracture is the square cross-section. If this pacifier has triangle or other cross-sectional shape, it could be broken more easily. I think the square shape is good decision for this pacifier. This study also has the effect from the pitch. Pitch means the distance between the cutting edge. So if a file has more thread, that means the shorter pitch. The shorter pitch made higher stiffness and higher torsional resistance, as you see in this graph. This study also conducted to see the flexibility from the pitch and cross-sectional shape as the four previous study. We used the same standard models. The final element study showed that the slender rectangle one, the second one, the blue one, has lower stiffness and lower stress generation. And the more thread file, that means the shorter pitch made lower stiffness and lower stress generation, as you see in the graph, the blue lines. The bottom, you can see the shorter pitch instrument. So they show the lower stress generation. So this is useful when we select the new instrument. The reason why I showed you my some study before is to talk about the file systems from 80s. I was quite curious that why the company made so many file systems. Here you can see many file systems, but I realized that they are 80s, so that they made 8 systems, 1, 2, 3, 4, 5, 6, 7, 8. It's, I think it's too many. It's not my personal idea, but it's too many, so it's difficult to select. Anyway, I want to say this. Among the A system, I just show you 2 instrument systems with some information. I told you the cross-section has major role for the instrument properties. Here you can see the E-flex gold has 3 different cross-sections according to the instrument. Small files such as 19.2% and 15.24% has square cross-section. The next larger groups, 4% files have convex triangular cross-section, and the next 6% size of files has the smallest cross-section of triangles. If the 6% files have convex triangle or square cross-section, the file will be very stiff and it will be very dangerous to use inside of curved root canals. I would like to say that the company had a smart idea, or they studied my articles a lot. No one is answered, but I think that they have good idea about when they design the cross section of the instrument. Here is another one, the E-flex blue. Small parts such as 15 and 24%, they have a square cross section. Square is quite big, but the files are small, so they can accept the square cross section. Next larger group, 4% size 25, 30, and 35, they have a convex triangular cross section. The 6% files size from 20 to 40 have triangular cross section. I believe all these cross sections were decided considering their stiffness. This is nice idea that they have different cross section even in a same instrument system. They have to, all other manufacturers should accept this kind of concept. But the company, it is, you may need to make further detail for the first property for the all different instrument system. Here I copied 6 instrument system, but all the system have same word for their characteristic. It's just heat treated con control memory nighttime wire. They have to somewhat different characteristic for all each systems. I will wait there how they change the introduction for the instrument. Anyway, among all these systems nowadays, the third generation and fourth generation are most popular in the market. All the third and fourth are heat-treated instruments, and they have reduced number of instruments in their system. The reduced number means the number of instruments. Especially the reciprocating systems, they were promoted as a single file instrumentation. They say we can shape the root canal using only one instrument. Actually, some root canals we can shape with only one instrument, but we may use 2 files sometimes, and sometimes we have to use more. But anyway, in this movie clip, uh, you can see how fast the reciprocating system and uh, for only one canal usually takes less than 30 seconds, something like that. It's quite useful and efficient instrument system. So comparing traditional systems and the most recent popular system, you can see the reduced number of instruments. Traditional systems have more than 4 files, but recently they have only 2 or 3 usually. No more than 3 instruments, I think. It means that time to exposure the root canal to the sodium hypochlorite because the shaping time is reduced. So we are doing shaping using the files. We have to use the files, of course. It's mandatory instrument and mandatory procedure. But we cannot shape all the microstructures as you see in the purple floor where the impacted tissues and microorganisms are located. We cannot shape those small areas. So we have to pour the sodium hypochlorite as much as possible. You can see here the pulp tissue is totally solved out after 8 minutes exposure to the sodium hypochlorite. Dr. Cutler, the inventor of Wave 1, he gave me this movie clip. You can see the untouched area still existing as red color. The shape area is green color and lots of microstructure in the right side movie clip. Um, it is very difficult to irrigate those very small and tiny areas. So Dr. Peters reported that larger amount of canal wall is not touched by the instrument even with the nickel titanium instrument. So it is very important to do the proper and sufficient irrigations. We learned at school the efficiency of sodium hypochlorite can be enhanced by the volume, temperature, and the contact durations. It's better to use as much as possible and good to warm the sodium hypochlorite and or heat is good. And the last one, the contact duration is much important for the apical canal area. We all agree that we don't want to irrigate the purple chamber alone, right? So we have to focus to irrigate the apical third. But some needle design does not help it and does not efficient to irrigate the apical third and apical 2 to 3 millimeters. We know that the side bent needle is good to prevent the sodium hypochlorite accident, but As you see here in the figure, the apical canal has less irrigation pressures. It means that it's not so effective to irrigate the apical 2 to 3 millimeters. In this study, whatever needle type we use, we can see that the shorter insertion of the needle to the root canals, they have lower irrigation efficiency, especially with the side bent needle, the most right side, you can see that uh, uh, the pressure irrigation is not enough to irrigate the apical 2 to 3 millimeters. So I don't like these side bent needles. So actually, the most left side, you can see notched needle. With the photo, small photo, I actually use this irrigation needles. The size 30 is usually recommended for efficient irrigation, but the size 27 gauge is almost effective and efficient as much as size 30 gauge. So the 27 gauge is the size is almost same with the it's 0.41 millimeter. So it is almost similar with the size of 25, 7% or 8%. So it the 27 gauge needles can go to the 8 plus 3 millimeter level. I think it's enough. So then we can irrigate remaining apical 2 to 3 millimeter with a slight injection, not injection, just we can pressure and the irrigant may go out and irrigate the apical part. As like it, the efficiency of irrigation is decided by the preparation size and the depth of needle insertion to the apical end. You can see here the size 25 or 6% is not sufficient to irrigate. You may see that it's quite very small, but on the right side, the most left one, they are drawing the 25 or 6 instrument, uh, prepare the size. Then what about if we have very small canal by minimal invasive instrumentation? Then how about that after that? We also need to compensate, as I told you before, the reduced exposure time to the sodium hypochlorite by, by the reduced number of instruments. We have to compensate it. The shaping time is recently very short. Here is the answer. By using this device, sonic or ultrasonic, we can increase the efficiency of the irrigation procedure. And also we can reduce the time consuming for irrigation the root canal spaces. It shows that activated movement by sonic and ultrasonic. The left one is sonic one. I don't like it actually. Always use ultrasonic. And right side is my case where I remove the calcium hydroxide on the second visit and have a look at the second. You can see that when we turn on the power, from the canal spaces, the debris are coming out and floating. The coming out debris are maybe the calcium hydroxide debris. And irrigate again. You can make clean root canal. Of course, you have to repeat it twice or 3 times. I'm using usually the blue color flexible ultrasound kit from the Ultra X. So this is the second time to power the isn't. So it's quite less amount of debris comes out from the root canal. Okay, let's move. And there are so many articles they comparing the efficiency of sonic and ultrasonic activation. This study compared the efficiency to remove calcium hydroxide from the root canal spaces. This article report the passive ultrasonic activation result in significantly lower amount of calcium hydroxide remnant in the canal compared with the sonic irrigation. Most of the articles, I think more than 60%, something like that, they report that ultrasonic is much efficient than the sonic, especially at the apical area. The ultrasonic is always better than sonic, so we have to use the ultrasonic. Sonic is not good at all, I think. So, and also like the endo activator and some other instrument, they made of epoxy, or they sometimes they are quite bigger than ultrasonic metallic ultrasonic tip. So sometimes contact with the canal wall, and the contact made its movement and effectiveness uh, will be restricted, and the efficiency will be reduced, of course. So it's not good if you use the epoxy resin tip or some other material tip. You need to care that the tips are not contacting from the with the root canal walls. That is the way to make the efficient irrigation of the sonic or ultrasonic tips. So here you can see some figure copied from Google. Ultrasonic make the cavitation, as you see in the left side, and right side you can see the actual node. Is the cavitation activation make the node along the ultrasonic tips. This photo was taken a few days ago for today's lectures. There are three tips from the 80s, gold color, blue color, and silver. I heard that the upper drawing may have some fault. Maybe the bigger one, right side, is correct. So the gold color is the most steep one. So they say the manufacturer recommend to use it to remove the broken instrument. But in my clinic, I use always the blue one when I irrigate for the ultrasonic irrigation, and also when I do the fracture fragment retrieval, I use this blue one. After making some spaces using another the diamond coated ultrasonic tip around the fragment, we may use this ultra X tip to make loosening by the ultrasonic vibration. Then we can remove the fracture fragment. Not always, but it works sometimes. This is movie clip that I'm trying to remove the fire fragment. Have a look, short moment. I think we all know that the garage kit is also good, but not so comfortable to purchase it in Korea, and also it's quite expensive. So we can do it in case the fragment is not located under the curvature area, not so deep area. I use the gate driven drill, and by cutting the up end, it can be used to make some lumen for the ultrasonic tip activation. So this is the first step. Then we can see the top of the broken instrument. After that, I use the diamond coated instrument to make space around the broken instrument. Sometimes during this procedure, the fragment comes out and repeat this procedure 2 to 3 times. I may skip somehow. And now you can see I use the Ultra X automated. So we have to use two types of ultrasonic. One is a diamond coated one that is used for make space, and this one is used for make vibration to comes out, the fragment comes out. Yeah, you may not see that the fragment is comes out and attached to the canal wall. So it's quite difficult to take out, but when we irrigate the root canals, the fragment comes out together. So this is simple example how we can remove the broken instrument. File retrieval is not the main topic today, so I just talked to you that using the ATIS Ultra X, it is quite helpful to remove the file fragment. Not all cases, but in some cases, visible cases under the microscope, and not in the very severe root canals. In moderate or straight root canals, we can remove the fragment. This is another case at the second molar, quite long file fragment you see, but it has been removed by using the same technique. Let's go back to the minimal invasive instrumentation. You know that the SAP system, self-adjusting files, we call it SAP from self-adjusting file. This is quite innovative instrument. SAP has the mesh structure and do not rotate at all, but moves with oscillation motion. And we made the final element model of the SAP, as you see like this. And when we cut this model, we can see simply the cross-section of this SAP instrument. The design of SAP is hollow cylinder, no mass of alloy. So it just have a shell of 0.1 millimeter thickness. Actually, as you see in this lower bottom area, you can see that there is some dot, only 2 dots, 3 dots, something like that. So there is no actual cross-sectional area, just dots is, that's all. So it's nearly non-cross-sectional area. So that's why they can change their shape inside the root canals. You can see that the fire goes into the root canal and they change their shape. And also we could measure the how much stress generated during their movement. So in this study, we compared the stress generation by SAP and compared with propyl and protapers. As you see here, the SAP made lower stresses than other two instruments. It's about 1/10. Very small stresses are generated. So we can say the SAP make minimal stresses on root tentin during the shaping procedure. It's quite a very safe instrument system, but it was quite expensive. Dr. Cohen, the author of Essay of the Root Pulp, he posted in his Facebook for this article, and he mentioned that clinicians should be care not to make apical crack when we shaped at the final 4 mm levels. Uh, that may bring result in the future the vertical root fracture. So I may recommend to use the very soft instrument, that is the heat treated instrument. So let's have another instrument. Here is another, this is very interesting. The name is True Shape. As written here, it has a shape of curvature. It has a spring-like action, so it allows to preserve more dentinal structures without removing not much dentin material. And they can keep the original root canal uh, walls. It is very irregular itself. We can preserve that dentinal walls. And this per XP endo systems, it also make actual, uh, it also permit the irregular canal spaces after shaping. It just rotate, but from the special design of the instrument, it can touch the very deep area of the root canal spaces. So the result after shaping, the root canal wall is not very smooth. They have irregular spaces, like in this figure. The many innovative systems, including SAP and TrueShape and this XP Endo Shaper, the shaping procedure will make the very irregular canal wall and irregular canal spaces while keeping their original canal spaces. Then, in the minimal invasive concept, we don't concern about the apical size because the instrument only have one instrument, the tip size was 21, something like that. But we are focused on the cleaning procedure. Then how we can fill the irregular canal spaces as like we saw before. This irregular canal spaces is quite difficult to fill with the garacultures. Let's go back again to the basic principle of endodontics. For a good prognosis, we need to have complete sealing of root canal spaces. The poor obturation will bring poor prognosis, of course. We have common obturation technique, lateral condensation and vertical compaction technique. Actually, I learned, maybe many of you learned at school, the single cone technique is not recommended uh, in our practical practice in the clinic. But as you see here, the single cone technique is showing good performance, while the vertical method has some spaces for microorganisms. They have the bacterial leakage. So we can say the important thing is not the technique, but the sealing itself. Sealing is much more important than what 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 technique we have used in. For the 3D sealing, three-dimensional sealing, we have to use the semi-solid carapace, and definitely we have to use the sealers. This is important point. Single cone technique, also known as AKA paste-based obturation. You may understand why it is called as paste-based, because by using single cone technique, larger amount of canal spaces will be occupied by the sealer, not by the obturation. So we can call it paste-based technique. Just fill some sealers, maybe in the middle root canals, and insert the cone and cut at the carapace remnant at the orifice level. This is the procedure. After scissoring at the orifice level, we just compact at the top of the carapace. There are so many calcium silicate sealer, I call it CS sealer, calcium silicate sealer in the global market. Some people called it MTA sealer, but it's totally wrong. Not the MTA sealer. It's calcium silicate sealer. MTA is MTA, and it's very mainly composed of powder. If we fill it, we fill the root canal with MTA, we cannot remove it after setting when we need it. But the sealer is sealer, so we can remove it when we need it to remove. So we have to call it calcium silicate sealer, not the MTA sealer. I have tested some CS sealer with and compared with the epoxy resin based sealer. The first main difference between the epoxy resin and calcium silicate sealer, is the acidity. While the epoxy resin sealers have some acidity lower than 6, something like that, but the calcium silicate sealer shows higher pH, around 10 or more. This is the main factor for the good biocompatibility. Here's another study from my group to compare 2 epoxy sealers with 3 CS sealers. We checked how much affinity, from those calcium silicate sealer to the human PDR cells. As you see here, there is no cell attachment on the epoxy resin sealer on the left side, but on the right side, the cells shows good attachment on the calcium silicate sealers. And also, we checked the effect on the osteoblastic activity. All the CS sealers, calcium silicate sealers, showed good differentiation of the osteoblast, as you see here. It's almost same with the positive control. This might be related to the apical healing. As you see here in this radiograph, only 3 months after of the root canal healing, the apical lesion was healed quite well. So maybe the cellular properties bring this kind of good result. Okay, let's think about again the minimal invasiveness during the obturation procedure. Always the stresses are concentrated on root dentin during the filling procedure, not only in the vertical compaction, but also even in the lateral condensation technique. The stresses may be concentrated at the apical end during vertical compactions. This study is another evidence that we have stresses by the root canal filling procedures. The author, Dr. Borsos, is my mentor for the final element study. This evidence are proving that the filling procedure may have some stresses and may have some hazard effect on the root dentin integrity. On the other hand, there is no pressure required to fill the canal space using calcium silicate sealers and single cone technique. Just simply fill the pre-mixed paste in the root canal and insert gutta percha cone to the end. And then gutta percha cone may bring some sealer to the apical area. Usually I do some pumping motion to make it competent. So pumping motion is quite helpful to carry the sealer to the apical end. We can do just you see in the movie clip. And then we can cut the orifice level and just simply pack at this level. So there is no pressures. So here we compare the efficiency between single cone technique and the conventional continuous wave technique. We measure the filling time, and also we evaluated the void after filling in the radiographs. Some cases have small void in the radiograph, as you see here. You can see 2 void, and with the arrows indicating in the right side radiographs, this void maybe I think is okay for the clinical view. The occurrence of void were similar between two techniques, as you see in the right side box. But the filling time of the single cone technique was just half of the continuous wave technique required. So we can say it's the single cone technique is more efficient for us. We have another study to compare some calcium silicate sealers. We compare the physical and mechanical property, and it is recently published in Australian Endoscopy Journal. I don't want to compare the value today, but the probability, I would say the probability is very important factor to fill the irregular spaces by doing the pressure release technique. We don't pressure, so the sealer should flow to the irregular spaces, very small and deep area inside the root canal spaces. So it is very important. For the radiopacity, if the sealer head has higher than 5 millimeter aluminum thickness, it would be valid for our clinical viewpoint. We can distinguish from the filling material and dentines. So most of them are good enough, but the thicker radiopacity, usually the clinician like it. So it's almost done. Here you can see the MTT assay. The epoxy resin sealers, as you see here, it's indicated it very low. The cell viability is not good. But the other calcium silicate sealers, they have good compatibility, cell viability, even it is very early stage of the sealer mixing. So, but for the epoxy resin sealer, after setting, maybe 3 days later, the cytotoxicity comes down, but we can say from the beginning, the calcium silicate sealer is uh, very good for the biocompatibility or our initial adaptation for the patient when they accept the filling material. It's a very nice point of the calcium silicate sealers. This might be the last slide. You can see another good evidence of the cell attachment on the calcium silicate sealers. They have much better biocompatibility than the epoxy resin sealers. All these four sealers, they have good cell attachment on the sealer materials. You can see the well-living cells there. I'm going to close my talk today. It's almost 1 hour. The minimal invasive concept is good to keep our natural teeth as long as possible. But as I talked in the beginning, the access cavity should be given to permit efficient shaping and efficient irrigation to remove the bacteria and infected tissue. For instrumentation, it's better to use a heat-treated instrument, especially for the apical part, for not to make crack initiation at around the apical foramen. And after the minimal shaping, we may use ultrasonic adjunct for efficient irrigation to compensate the short instrumentation time. And we can use the single cone technique using calcium silicate sealers with pressure release technique, without pressure, I mean. So these are all from today's talking to your office.